How's that doing? I hope that's okay. I hope it looks okay. I've back to just me and my phone streaming off the 4G because I can't get this working at school. But you know, I will get it working, all right. But I wanted to do this one because I've had a really nice week actually. I've had a really nice week because I've been listening to some of my students that got grade 9s in physics last year, and really listening to their kind of story has been really, really useful. So that's what this stream's all about, is looking at their story, and I'm interested to hear what your kind of story is. Maybe you are an A-level student and you can give someone a tip to how to get a grade 9 or how to get just an 8 or a 7 or whatever your best kind of grade was, what your kind of study tips are, what you're thinking about studying, you know, in A-level now or GCSE now, and kind of asking me any questions about that would be really, really useful. But as I said, I was really interested by the kind of journey that these kids went on to get those grade 9, so let's talk about that. If you are watching this recorded, as I know a lot of you like to do, then make sure that you're subscribed and you have notifications so you do see them live and you can actually interact, because that's, you know, it's all the point of being live, isn't it? Okay, so as I said, well, these kids, they got grade 9s in the new GCSE. Yeah, so I mean, the new GCSE is hard. They got grade 9s, and loads of my kids did really, really well. I got like 20% grade 9s, and it's not me that got those 20% grade 9s, so it was really interesting to listen to what these kids said about what they felt worked. And, you know, they didn't all say, "Oh wow, it was your YouTube channel was absolutely fantastic, sir." Okay, a lot of them appreciated that, but really it came down to a few things. And they all said this. You have to want it. All right, that's the first step. So, Sandrine, if you want it, then that's the first step to doing really, really well. And they all went through that period that you're probably going through right now of coming into GCSE Physics, coming into all your GCSEs and thinking, wow, this is hard. And they're at that point now with their A-levels thinking, wow, this is hard. And we all have to go through that learning curve. But you had to want it. You have to really, really want it. That's the important thing. And they all said as well that they weren't that keen on these things, these CGP revision guides. Now, I like CGP for one reason, that it's kind of thin. And it gives kids the idea they don't have to remember much. But that's all it really gives you, is this kind of like kind of basic facts. What they all said they really, really liked were these textbooks, the caboodle textbook we call them, because actually we give the kids access at my school to a kind of e-copy of this book. So maybe your school has something like that, or maybe your school has kind of the full textbook, course textbooks that you can actually go to, and you can use them and you can study with them in school. Maybe you can borrow them, maybe you can check them out at the library at school, maybe you wanted to buy them. So I've actually put the link to this one if you wanted to buy it from Amazon in the description here. So they all said what was good about that was the depth that it went into and the kind of detail and the questioning that gave them access to the grade 9 understanding. And I think that is really, really important. I don't think just relying on this gives you access to grade 9. CGP do a bunch of resources that are aimed at grade 9, so you might want to check those out as well. And I've got videos where I've looked at those actually. But I think really there's no kind of substitute for a really good course textbook. And I also often recommend the Physics for You textbook. There's no substitute for that course textbook. Okay, what else did they say? They also talked a lot about the mock exams and how useful they were. So if you're doing GCSEs now, you're probably coming into a period of mock exams. Exams are so useful because, well, they talked about consolidation. They talked about, like, you know, you repeat that learning and you do the mock exam so many times. And it was really nice to hear that although they were quite, they're quite anxious individuals by their own admission, they weren't so anxious by the actual exam period, because by the time they got there, they just felt like it was another set of mock exams. So I think that was a really nice kind of thing. I was really pleased to hear that they weren't really, you know, and actually one of them said that, you know, I quite enjoyed the exam period because I got to go home, you know, in between exams, I got to study on my own, I got to manage my own time, all those different things. So it was really nice to hear that. Also, they talked a lot about past papers. They talked about, even though these GCSE, the 9 to 1 GCSEs are new, they still found going and doing the old past papers to be useful. And I would suggest as well that although they're quite new, one thing about 9 to 1 GCSEs, they're all quite similar, because they have to more closely adhere to the same kind of the QCA, the curriculum, the people who decide exactly what needs to be in the GCSE, they have to closely adhere to that same thing. So they're all quite similar. So if you look at a different exam board, you can often find that they're pretty darn similar across the lot. And the other thing that all of them had in common was they were never just satisfied to just know something. They all wanted to understand something really quite deeply. And there's one thing one of them said, like, I'm not one of those type of people who can just look at something and do it. I have to understand it to really like remember it and kind of, you know, be able to answer questions on it in the future. And I thought that was really, really key. And really that's about knowing your gaps, finding your gaps, and going home and doing something about it. And I think that's really, really important. So I don't know, you tell me, where are you guys out there watching right now? Are you at the start of your GCSE, at the end of your GCSE? Are you at the start of your A-level, end of your A-level? And how are you feeling? And whereabouts on that kind of journey are you guys now? Are you struggling at the very beginning? Are you getting up to speed and worried about it? Or have you got over that hurdle? Maybe you can tell someone, no, it does actually get easier once you're in year 11, maybe, Mahir. When it starts to get easier and you've got your head around the kind of basics, the equations and the calculations and the kind of idea of proportionality and everything like that, maybe then you know, you found your way into it. How did it go for you? Let me know in the main comments as well if you're watching this recorded. I'd like to plug, this is my book backwards, it's not written backwards in the real thing, Memorise Equations for GCSE Physics, which I think is one of the first things to do if you are in year 9 or 10 or even in year 11. If you don't know all your equations for the new GCSE, then that's a really important thing for you to do. And I'm pretty sure there'll be a link for that down in the description as well. It's got all the equations as little flashcards, and it's got some questions to practice them. So I think, again, that was, don't just remember, practice using it. And if you practice using it, then you'll automatically remember the equations as well. You know, what tips do you have? I mean, like, yeah, that's exactly what I'm chatting about. I mean, this is the experience here of like getting the best grades, right? So they also have to want it. You have to want to do it. They said using the detailed textbooks was really better than just using the CGP. They said making sure you focus on the mock exam so you feel like you've been through the mock exam, the actual exams 3 times before you get to the real thing. Making sure you're repeating the learning in that way, you're doing past papers, and you're not satisfied with just being told something and actually, you know, you're not satisfied with just being told something, but you want to understand it. So I've put the links down to this one. This is for OCR Gateway, which is the one we do. I put a link to Edexcel and the A textbook as well, because I think that would be a useful one for you guys to have. The other thing that I always think about is let's go back to that first one. You have to want it. Well, you have to want it. Well, like, do you really enjoy studying? I have those people who got the grade 9s, they quite like studying. Not the like process of sitting down and being on your own and kind of working through some really hard things, but they quite like finding stuff out. And it, like, sometimes when you're learning something, you get a little pang of like, wow, this is really, really cool, right? And I get it as well when I'm teaching. And I was just reading something that my year 13s are going to go on to pretty shortly, which is thinking about particle physics, but it's thinking about particle physics in the context of the very beginning of the universe, right? And I was reading this little bit of text, and the universe, as you'll know, start with a Big Bang. The Big Bang is a bad name for it, really. The Big Bang theory should really be called the theory of universal expansion, or we should be talking about inflation at the start of the universe, right? So 0 seconds, the very, very beginning, what you had was a period of inflation, a very, very rapid expansion for 10 to the minus 18 seconds. Now, we know this, we have evidence of this, but this is just like, wow. 10 to the minus 18 seconds is an incredibly short period of time. For us to understand discrete periods at the start of the universe that are this length of time is incredible. So you had this very, very rapid expansion called inflation. And then from 10 to the minus 18 to 10 to the minus 12 seconds, you had this quark-gluon plasma. So everything in these little fundamental particles called quarks, and they're kind of being held together by these gluons, okay? But there are no kind of discrete kind of other groups of particles apart from just being these quarks, which are ups and downs and charms and stranges and tops and bottoms, and these gluons which carry the strong nuclear force which hold them together. Amazing, right? And that was until 10 to the minus 12 seconds. So let's imagine all those zeros before 1 second. This incredibly short amount of time, this quark gluon plasma. And then you had the hadron era, and the hadron era is a long period of time, was from 10 to the minus 12 seconds to 3 minutes. So that means a hadron is basically a group of quarks being joined together by gluons. And now these hadrons are being joined together, and you maybe are starting to see distinct protons and neutrons. They're examples of hadrons, right? And then from 3 minutes to 13 minutes, you're starting to get nucleuses being made, nuclei being made. It's called nucleosynthesis, right? 3 minutes to 13 minutes long, and you're getting essentially hydrogen and helium being formed, like nuclei of them being formed, not atoms yet. So you're getting protons and neutrons sticking together with a strong nuclear force, and you're getting pairs of protons and pairs of neutrons sticking together to make helium nuclei. And the really interesting thing about nucleosynthesis is by the end of this period of time, then the hydrogen and helium in the universe is in the same ratio it is now. And basically, most of the universe is still just hydrogen and helium, because most of the universe is really quite high energy areas or void. high energy or void. So in those high energy areas, you've still got hydrogen, helium, and they are making all the friction, starting to do nuclear fusion, and well, they're stars, or they're giant clusters and groups and globules of these massive stars, giving out all of this energy as they annihilate and form matter and form energy and make larger atoms and then explode in supernovas, and all these fascinating things that are going on in the universe. And that's up till 13 minutes. And then from 13 minutes to 3,000 years, you have the plasma era. So still haven't got any discrete atoms yet, right? You still have just got these nuclei, and there's so much energy in this tiny little universe that we've still got. Okay, this initial universe, this very, very young universe up to 3,000 years, you've got so much energy that the electrons can't hang on to the nuclei. The nuclei can't hang on to the electrons. There's too much electromagnetic radiation just bashing all these particles about. There's no stability at all. And then you start to get atoms. So as it expands, it starts to cool, which is a bit like thermodynamics, isn't it? It's a bit like gas laws. You start to see atoms, and you have the era that we're at now, which is this kind of expanding universe, cooling down, tending towards stability all the time, tending towards low energy and dissipating all that energy, gradually becoming more and more and more stable and less energetic as we go. But we're still at this kind of, completely fierce universe. And then the fascinating thing is, of course, we know that the universe is accelerating. So I don't know, I was reading that earlier, I was thinking about this tiny little period of time, and I was just thinking, wow, this is why I want to be a physics teacher. This is why I enjoy my job. Right, well, Risha just asked, which revision guides do you recommend? We already studied from textbooks, but a revision guides are also useful. Yeah, revision guides are useful, but as a reference of what you need to know, treat them as like an extended specification. That's another thing that those students did, is they found out their own weaknesses, and a lot of them were doing either like ticking off bits in the revision guides, because they give you little kind of checkbox pages, don't they, or using checklists that you can buy, get from your teachers, or using just by printing out the specification on them, so then just making sure they were targeting the bits that they didn't get, rather than working on the bits that they did get quite well. So that's something I think that going through those mock exams really helps with as well, is identifying your own bits. I hope that helps. I was just thinking about that kind of age of the universe kind of story we've just been through, and we were just doing Hubble's law in GCSE, right? Now, you're probably not going to be able to see that because I think my screen's still mirroring. Is it still mirroring? I can't figure this out. I was trying to get this streaming through my laptop because the screen's mirroring. I don't want it to do that. Anyway, that's a graph of recessional velocity against distance, right? And let's look back to front, and that's Hubble's law, basically. Basically, Hubble found out that the galaxies he looked at were all being redshifted. They were moving away from us, and he found out that the further they were away from us, measuring the distance by the standard candle that you'll come across in A-level if you do A-level, that's the way to measure distance to a distant object in the universe. The further away they were, then the faster they were going, and they were proportional. So the recessional velocity is proportional to the distance. V is proportional to d. And the gradient of that we call the Hubble constant, right? The Hubble constant. And it's got inverse time units. And it turns out that the Hubble constant, which there's Hubble's law there, V is h naught d. I think it's reversed again. I'm sorry about that. It's mirror imaged. The Hubble constant is 1 over the age of the universe. So the age of the universe from Hubble's law comes out at 13.7 years. Now, I think that's really, really young. If you think about those initial periods, we're talking about periods of 10 to the minus 18 to 10 to the minus 12 seconds. It's gone a long way since then. So that really makes me want it. Those little pangs of kind of fascination, those little pangs of interest, like, wow, this is actually well worth teaching. It's well worth learning. I flipping love it. Okay, I flipping love learning this stuff. I love teaching this stuff, and I want to get on with doing it, right? So I've got a question for you guys. I'm going to answer your question just in a moment. That just bonged up there. Do you enjoy studying? Are you loving it? Because if you want those grade 9s, you've got to find a way. You've got to find a way to start loving it, right? Have a look. If you have time, you please explain wave experiments and how to revise them. Okay, is that for GCSE? Well, I think it probably is, yeah. So, yeah, the wave experiment is really cool, actually, in the GCSE. So there's a few ways they do it, don't they? They do it with a tray of water, and you can make these ripples, or you can do it with a slinky, and you can make them as well. So basically, the idea of those wave experiments is V is F lambda. So wave speed is equal to frequency times wavelength. And essentially, they're inverse there for each other. So the wave speed is fixed in any given medium, any given situation. So if you keep the wave speed fixed, you don't change the medium, you don't change the tension on the string or anything like that, then If you double the frequency, if you double the frequency, you should half the wavelength. If you double the wavelength, you should half the frequency. That's the principle of that. What we'd say how to revise experiments in general is the evaluation is the most important part, right? So you need to get yourself a method memorized, okay? Get yourself a kind of like an example of a set of results and how you'd analyze them. What graph would you plot? There, if you plot f against 1 over lambda, you should get a straight line, right? But all that's very, very important. That's good memory work. But actually, if you just revise the evaluations, you're kind of revising those methods and you're kind of revising those mathematical models anyway. So that's what my kind of thing to remember about practicals is always the equipment you need, the procedure you're going to go, the improvements, how could it be better, and the actual mathematical models. I've done that. If you search guerrilla physics experiments, guerrilla physics how to evaluate practicals, I've done quite a few videos on how to actually do that and how to study for that. So have a little look at those bits there. All right, I'm almost at the end of my little thing, so now I'm just over to you, really. I hope that's been an interesting little story for you. How they got grade 9s, the things that they did, the things that they actually used to make sure they did get the grade 9s, okay? And that was really fascinating. It was really fascinating to hear what they said. These kind of really, it's quite an inspiring story, really, to hear how they got those grade 9s. Okay, so another thing, do you enjoy study? Let's hear that in the chat. What ways do you get yourself going through, get yourself motivated to keep yourself studying, to do those couple of hours every night on the way into the mock exams and the way into the real things? I'm going to show you some of this. So I filmed it because, well, I'm doing a few videos for my school YouTube channel and I'm going to do a few videos with them. I've got them all filmed up. I'm just doing the editing just at the minute. I'm going to put some of them on my channel. It'll be something like how they got a grade 9 in their GCSE Physics. So you can have a little look at them and actually hear it from the horse's mouth, hear what they should do. The other thing I want to say is they were talking sometimes about they weren't sure if teachers always cared throughout their career. They weren't just talking about my school, they were talking about in their middle schools and in their primary schools and everything like that. And I thought that was really interesting. And teachers do really, really care. That's why we're in a job, right? So if you're thinking to yourself, well, I've got a physics teacher, maybe they're not the best. I get a lot of, it's nice to hear, I wish my physics teacher was as cool for that. I bet Kay Johnson, maybe your physics teacher, Kay Johnson, what did you think of them? Was that a decent physics teacher or not? But really use your teachers as the resource that they are, because they really want to help. And if you go badger them and you go say, oh, I'm not sure how to get this, I don't really understand this bit, I want to get it, I want this, I want to make sure that I can get this grade, I really want that grade 9, they want to help you, they want to put that time in there. So yeah, the best. Yeah, thanks Kate. All right, I'm lucky because I had the best students as well. I really like this one. Okay, yes, you do need the variables. Okay, but they're going to be contained in the equations in physics. I like that point. Make a folder with each experiment, hypothesis, method, equipment, results, conclusion, evaluation. Then you have all the practicals all together, and you just revise them. And Smax says the practicals are the key. Yeah, the practicals, the experiments, understanding them and evaluating them, make sure we're working at the highest level. Yeah, that's the important thing, okay? Making sure you're working at the highest level. You want the grade 9s, you want the best ones. You don't just memorize, you work at the highest level, and the best thing to do about that is going to be the practicals. Do you watch The Flash? No, I don't, but is it good? Tell me if I should. I'm always interested in watching TV, and we're just finding time to watch TV, really, at the minute. Anyway, that doesn't matter. Nobody's answered this one though. Do you enjoy studying, and what is it that makes you motivated to go on and study? Because I did get the feeling that those people, they certainly didn't mind studying. Yeah, they were talking about ways to make sure they were relaxing. The one tip: if you make plans, you can't go back on. If you make plans with people, you don't want to let people down. So make plans and then you always take a break. But do you enjoy studying? What do you do to make sure that you do enjoy studying? So you're going to see those videos, those stories, if you make sure that you're subscribed. Do share this one as well with your friends if you found this one useful. I'm going to get off and go home now. So I hope that was useful to you. This is GCSE Enable Physics. I'm going to try my best to keep doing live once a week for you guys, and I'm going to keep trying to get my laptop going so it can stream live, so I can actually do things like show you visualizer at the same time. If not, I'm just going to from home at some point. I enjoy the challenge of study. Yeah, I like the challenge of study as well. That's why these textbooks always have structured questions up through to the grade 9. And yeah, studying is good, especially if you can find the interest, if you can understand what you're told, to find that interest in studying, absolutely fascinating. And well, you know, learning is the best, and that's why teaching is the best, because we're good teachers, we're always learning all the time. And as I said earlier, I just wanted to share that with you, that kind of little story of the universe and the story of the kids who study the universe. And yeah, okay, all right. Cheers then. All the best.